All right, in our video here, we're going to be talking about how to construct histograms and then a branch of histograms with cumulative frequencies called ogives. A histogram is for quantitative data. It's going to look a lot like a bar graph, but the bars themselves are going to join together. It is continuous on a number line. And the order matters, where when you have qualitative data and you do a bar graph, you can kind of move them around if you have that nominal type data. All right, so let's go ahead and look. This is going to be some final exam scores for a calculus course. The first thing that I want us to look at is the class width of the frequency table. It gives the lower bound and the upper bound in the table, and if I do that subtraction of lower bound and upper bound, I see that my class width is of size 10. All right, it also wants me in this example to expand the table to include some relative frequencies and cumulative relative frequencies. So let's just add those in. Remember, relative frequencies mean we're going to find the percents. So our total, let's go ahead and find that total. 5, 10, 30, 40, and 15. Oh, it's 100. Oh, and look what I could have done. I could have just looked right there. All right, well, this won't be too bad because I'm going to just divide by 100. So 5 would be 5%, 10 would be 10%, 30%, 40%, and 15%. And then let's do cumulative. Right, so 5%, 15%. When I add here, I get 45%, 85%, and then 100%. So that's our expansion. All right, so let's now look at creating this histogram. We're going to have an x-axis and a y-axis. I'm going to include my lower and upper bounds for each one of these, all the way up to my highest upper bound. And then on my y-axis, I'm going to have frequencies. And I just did a little break here. You don't have to say that break, but I just did that because it's a number line. And maybe we label these as test scores. All right, and then I need my frequencies to go all the way up to 40. So I'm going to just go by 10s, 20, 30. That's 40. All right, so 5, and you make this go all the way over to the upper bound. So lower bound to upper bound for each one of your classes here. Okay, 10. And sometimes we'll write the frequencies on top of them. That's normal practice as well. 30, 40, and then 15. All right, how does this change if we use relative frequencies instead? It actually wouldn't change because instead of a count of 40, if I just change this to relative frequencies, the scale is gonna look exactly the same out of 100. So nothing would change if I used frequencies or relative frequencies here. All right, let's look at a frequency polygon. This looks very similar. You want to do your little break in your graph. Let's go ahead and label this. And what you're going to do is you're going to then use the frequencies here. And on that end point, the upper bound endpoint piece, that's where your 5 would then go. Okay, and so we're going to do that. 10 right there, 30 right there, 40 right there, and then 15. Okay. You can see that it has a very similar shape to it as the histogram. It just is a different type of frequency diagram that you can use for quantitative data sets. The reason that it's really nice to look at, though, is because it will really help you with your ogives. So ogives look like the frequency polygons and the histograms, but we're going to use cumulative frequencies in order to create this. Therefore, what we have to make sure we do on our y-axis is go all the way up to 100%, because at the very end, I'm going to start, okay, with nobody having below a 49.5, and then everybody at the end being 100% of my data. Okay, so here's my 50th percent, and let's make sure we call this cumulative relative frequencies. All right, let's go back up to our cumulative relative frequencies and see. So what was the cumulative relative frequency here? Okay, so 5%, it's a little. Okay, 15, 45, 85, 100. So 15, 45, 85%, and 100. All right, so notice that where the highest change here and like where the highest bars are here is the steepest part here. Well, that's because you're adding the most things, right? Your cumulative relative frequency is increasing the highest there. And it also allows for us to see where the median is going to lie. So our median is always what cuts the data in half. There is another video that is just on mean, median, and mode, but you could look here, okay, and see, I think I was off just a little bit. That might need to be like 45, like down here, right? But you can see that like the median score is going to occur in that bin width. So that's where these are really nice to use, and they again show off the cumulative frequencies really, really well, and you can see where that biggest rate of growth is going to be on these types of graphs.